Let's take a closer look at the Vernier Video Physics app. On the first screen, you'll just be presented with a page where all of your past experiments that you've done are listed out where you can get back to them at any time, and it's also the screen where you can create a new experiment. Whenever you click on the plus sign, you can either choose to take a video or choose one that you've already taken, maybe in the standard camera app, or you could even look at some of the sample videos. Now, I've already chosen one, or I've already taken a video, so let's choose existing. Let's navigate here to the one that I've already chosen. Now, in this video, you'll notice that I don't, let's come back to it. In this video, you'll notice that I don't actually show up to drop the car down the track for a little bit. So let's try to trim this video, and just like in other spots of iOS, that actually is available for us. So if I can trim this guy down, just like in the actual camera or in the actual Photos app, I can trim this down to about right there. Now, I'm going to click Use here and reduce the video size that I'm actually going to deal with. Let's hit play first down here at the bottom to make sure this is the video that I want. Yeah, that looks like exactly what I want. Let's keep watching to see if I need to trim off the back side there. No, that looks pretty good. I could have trimmed it off to where maybe it only went down one time from left to right, but let's click Use now. All right, and that's going to load our video here actually into the spot. This is where we're going to put points everywhere. But before we get started with any of that, we need to choose origin and scale. Now, the origin and scale allows me to actually tell the app how far the distances are and what to call their zero. So here's my origin. So I'm going to purposely set up my origin at the front of the car. Pinch to zoom works, so I'm going to zoom in here. And after I've zoomed in, I'll drag the origin to be exactly at the front of the car, right there, just before I release it. So as you can see, back, I'm using the slider at the very bottom there. Just before I release it, there is my origin. Now the scale is also, let me double back to the origin, another important feature. You see how this x-axis actually has arrows next to it? If you're doing a ramp lab, you can spin your x and y axis to actually get the x-axis aligned. Now, let's see if I can't get my x-axis back straight for this one. Oh, that's a little tilted. So there we go. That's approximately straight. Now, the next thing. This is the scale part. Drag it over some known distance. It's always good if you're doing just an indoor lab to have a meter stick for reference. If you're doing some outdoor lab, maybe something larger, because you do want your scale to, for the most part, have a relative size compared to the video that you're taking. So if you're doing an indoor lab like mine, a meter stick might work great. On the other hand, if you're doing something outdoors, you might instead want to go out on a football field or some other field that has lines marked off on it. That way you can actually know, hey, this distance is 5 yards. Of course, you'd want to convert to meters. And you can mark off a known distance that would be larger. A meter stick would show up so small on that the precision wouldn't be so good. Once again, pinch to zoom. So I'm able to cover that with my scale, and then I'm able to come up top, and I'm able to choose what that distance is, because it's not always 1 meter, right? 1, but for me it's 1 meter because it's meter stick 1, and then M 4 meters. Done. Very good. Now I can jump back over and actually start putting points on it. So I choose the points part, and I take my crosshairs, and I'm going to fast forward my video all the way to the spot right where the car is starting to get released. Now, down at the very bottom is a slider here, so I'm taking my finger on the bottom slider and I'm moving it back and forth here. Also, other features to note about this. There's a skip to the end. That's the triangle with the line over there on the right-hand side. Then the triangle with the line coming back to the left will get you all the way back to the beginning. There's also these circles with ones in it. That's to advance a frame. So you can advance one frame at a time going forward. That's the circle going around to the right. Or I can advance one frame going back to the left here. And that's actually very useful, especially with starting it out, because I want to start it out right as I'm starting to drop it. And you'll notice the first few frames, nothing's happening. So I'm going to go forward, 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 forward. You can see my hand starting to release. Now my hand's completely off. I'm going to take that as my first point right there. So I'm going to take these crosshairs now. I'm going to zoom in on the car. Now, whenever you're making points, you have to put dots at the exact same spot, or at least approximately, as to the best of your ability, the exact same spot on the object all the way through. Personally, I'm going to choose the front of the car. Now, you'll see in this video, the car is going to blur, and so I'm going to have to choose the front of the blur, which can get very difficult, but that's okay here. So I'm going to choose the front of the car. I'm going to line the crosshairs right there, and I'm going to hit dot. Now, every time I place a dot, it advances, the video advances automatically one frame forward so that I can move the crosshairs to the next spot and hit a dot there. If I ever decide that if it was going too slow, in this case obviously not, but if it was going too slow, and so I can't really see the difference between where it was and where it was and where it is now there, so the two dots would be in the exact same spot, you can come back and you can actually advance it a frame to try to see, maybe zoom in here, to where we can actually see the difference between it. Also, another thing, whenever you go back a frame, the dot that you put on that frame actually lights up in yellow, so you can see what dot aligns with what. So let's come back, let's go forward a frame, and I'm just going to go ahead and I'm going to put dots all the way down. So from the front of the car, notice how it's starting to blur here, so I'm going to try to do the front of the blur, if you will. Maybe right there, approximately right here. Now ideally, I would have chosen a scenario where the object was large enough that I wouldn't have had any blur, and the motion would have been large enough that I wouldn't have had any blur. Whenever an object moves very quickly across the camera, you're going to end up with this sort of blur problem. There, approximately there, approximately here. But since a camera actually takes, since a standard resolution camera like this, not a high-speed camera, actually takes a video at 30 frames per second, the image quality and the detail available is actually very good. Let's see, there's that dot, forward a frame, there's that one, there's that one. Even despite the blur, it actually comes out to be pretty precise. That one, that one. Now you can see I'm decelerating, I'm slowing down because we're going back up the hill. It's a lot easier to see where the car is. There's that one, and we start to turn around. Now I'm going to stop there for now. So I've applied points all across, and for now I'm going to come back, I'm going to rewind to the beginning, I'm going to hit play. Notice how all the dots light up as we go, confirming that I've got them all in the right spot. And once again, you can actually double check that at any point in time by going forward and backwards a frame to put all the dots in the right spot. Now, other features you need to see here. Over in the top right hand corner, you have a graph button, which we are about to use, and a send to button that you can export data or the video to other apps. Let's actually look at the send to button first. If you click on that, you can send the video into other apps and you can actually make a little video. The video is just what you're seeing right here, the video in front of your eyes, and then it quickly flashes, it does a screen of each of the graphs you're going to see here in a second. And you can do the video or the video with the points in there. Of course, you probably would want the video with the points. You can also export the data file. That's going to be very important if you want to export over to the graphical analysis app. Let's now look at the different graphs available just inside this app. Oh, before I move forward, I do want to point bottom right-hand corner, there's a track button. If the object's large enough and it's not moving too fast and you have a good contrasting background to where it's easy to see the object, sometimes it's good to make an object bright colored and then have it on a very dark background so it's nice and easy to see. You can actually move the crosshairs over the object and hit track down here, and the track button will try to automatically track the object. Now in my case, the car was moving too fast, it wasn't going to work. Now let's hit the graph button here and look at the type of graphs available inside this app. Now here I have an XY graph. Let's bounce back, I purposefully chose an object to move from left to right. The reason I wanted to move from left to right is I know that's the direction that everything gets graphed. So I wanted the object to move, if we look at our origin and scale, I wanted the object to move in the positive x, which is going from left to right. So whenever you're doing this, if you want the object to move positive x, make sure it goes from left to right. It's not a big deal if it moves in negative x. Just understand if you do right to left, it's moving in the negative x axis here. Also, if it goes down, it's obviously moving in the negative y, which is what is occurring here. If I didn't want it to move in negative y, I could have taken my XY axis and slidden it down instead of at the front of the car. I could have pulled it all the way down to the table. Then whenever I clicked on my graph here, where it's y-axis against x-axis, instead of my actual motion here, this shows kind of the shape of the motion here, which is the shape of the track. Instead of it being like this down below the y-axis, this would have been above the y-axis, starting out instead of at initial position of 0 in the y-axis, starting out with some initial position, some initial height. So here, this is basically the motion in xy of what occurred, and it looks just like the graph. Notice that we did not get up to the same starting height because, of course, there's friction. Swipe once over, and you get your x time graphs. Here, the top one, you have an x position versus time, and the bottom one, you have an x velocity versus time. Now, notice all of these graphs, they actually connect the dots, which is not a good thing in science, so you would have to imagine best fit lines and curves, try to figure out what's happening here. For example, this bottom one, x velocity, this first piece right here, coming from just around 0 seconds all the way up to just a little past 0.4 seconds, looks very linear to me, which it should be because the object is accelerating. And then from just beyond 0.4 seconds to somewhere around 0.7 seconds, even though it waves a little bit, that's pretty much a flat line there, which it should be, because as the car is moving across, let's actually come back to my video, here, right there at the bottom, in this area, right here, let me pull up the points part, and this part, and this part right here, it should be going at a constant velocity because it's flat there. And that's what it's showing. And then, on the last part, I have the velocity decreasing. That means a deceleration, which it should be because it was going back up the hill. So there you have xy, you have x position time and x velocity time. And then, of course, you have y position time and y velocity time for you to look at. Now, these connect the dots, but it is a pretty good idea of what's going on. Just be careful with the scales because it does zoom in long, long ways.